Hello everybody, here at the IFA Berlin online. Why should VR experiences synchronize reality? The short answer to this question would be this video, but to be honest, in reality there's way more complexity and way more benefits than just preventing collision. So let's explore this topic in the next 15 minutes and give you a short demonstration afterwards. My name is Julian Zietemann. I am the co-founder of 2Sync, and how this picture of me on the sofa came to be will be part of this presentation. So, what are we even talking about? I said VR is masking reality. And if we look at the term and its definition, that's what VR is doing. If we plot AR and VR on an axis, then we have VR on one side, and these experiences, you are in a virtual world, you're in a virtual reality, Wu thought, and you're essentially blocking out everything that's around you. And on the other side, we have augmented reality. We are enriching the reality, but still have this connection to your real environment. So both sides offer different advantages and disadvantages. So first of all, since you have this connection to the real world, you can walk around in augmented reality. You still have this connection to everything that's around you, and you have also the physical interaction with the objects. But if we talk about VR, we are in this virtual experience and in this virtual world. And of course, there are some experiences where you can walk around in a certain area or even experiences that match to reality. But that's a process that takes days to implement, and then you change the environment and the application is not capable of presenting the reality anymore. So let's say most of the users will never experience walking around or interacting with the objects around you. And in the end, same applies for multi-user capability. Through the connection to the real world, several people can interact in one environment in augmented reality. But for VR, the same applies as before. You just have no connection to everything that's around you. And if we talk about user acceptance and ignore facts like the general acceptance of a new technology or learning a new technology, a lot of users get motion sickness when they put on their VR glasses. So they get a headache and the utilization rate decreases. But, and that's the important point, users get immersed by VR experiences. You can experience situations you never experienced before and that you just cannot reach by just enhancing the reality in AR around you. So, wouldn't it be nice to combine both worlds together? What would an application look like if you combine VR and IR experiences? So first of all, you could walk around and interact in a VR experience. Why a VR experience? Because VR experiences offer these immersive feelings, and by adding the two elements of walking and passive haptics, you get an even deeper immersion into the application. And by doing so, you have this connection to your movement in the virtual world and your movement in the real world, and you reduce the triggers of motion sickness because your brain just connects to the movement in both worlds. And since you are located in the room because you walk around, you can even do this with multiple people and have this multi-user capability in one environment. So what does it take to make an application as I described, to make it reality? So what does it need? On one side, we need the spatial information from the user's environment. What objects are around them? What's the structure of the object? Maybe what's the temperature of the object? And on the other side, you need the virtual assets that you can put onto these real assets. And then maybe the most important point, you need this layer in between to combine the spatial information and the virtual assets. And that's exactly how the picture from the beginning came to be. I'm lying on a physical sofa, and on my headset I see a virtual representation of this world. And of course I'm just lying on the sofa, but I can also just stand up, feel the sofa around me. I could sit there with several people and I'm still in a virtual reality. And of course that's just one sofa, and I maybe could build this in one day, but think about a whole house, think about this whole booth. And we wanted to solve this issue in an automated way. So we developed a software development kit that extends the existing toolset for XR developers. And we offer 3 more core capabilities to make these experiences happen. First of all, we have a real-world description for virtual objects. So what size would a virtual object have in the real world? what would be the structure of the object, maybe the temperature. And then, since you don't want to build a virtual asset for everything that's around you, you want to have scaling logics that go beyond just up and down scaling. So how to extend certain objects in a different direction, how to combine objects, that's part of the scaling logics. And third part is the object relations. Think about a chest you want to place in your living room, and you don't want the key to this chest directly next to it. Maybe you want it somewhere on a shelf, somewhere in the other room, and this can be described with object relations. And then we still need the information from the user's environment, and we included a tool to scan the user's environment, and the applications developed with these SDK can combine both worlds. So for the user, and in the end looks like this. They can just take their normal environment. For a user at home, they can just scan everything around them, and then they can walk around freely. Or if you think about an enterprise context, you could just rearrange objects and have infinite different virtual worlds and experiences. Then you scan your environment. As I mentioned, we implement a tool too, but that's still in a manual way. But in the future, the headsets will be capable of scanning them on their own. They are already capable of doing so. And in the future, developers will have access to it. And then this process is even automated. Still, it just needs a few couple of minutes for whole rooms or whole houses. So it's quite fast. And then that's it. The application combines all the information and just render the virtual world in seconds. And that's how it looks like in reality. As I mentioned, you scan your environment for now on in the manual way. And that's nearly real time on the glasses, the world is transformed into virtual experiences, and then you can stand up from your normal environment in VR where you're just sitting or standing around and start walking around. Of course, that's in a gaming context to visualize it, but think about enterprise context where you could put every surface into an interactable, where you can simulate engine rooms, for example, and interact with the objects around you. And since you have this location inside the room, you can even do it with multiple people, and for example, in the gaming context, play together or play cooperatively. And this could be increased. Think about virtual conventions and so on. So there are a lot of possibilities, and the most important point, it's quite fast, and you can do it in unlimited environments with unlimited experiences. So, for example, think about the different gaming scenes you could implement, and think about completely different rooms that you can just scan in seconds and then transform into virtual worlds. So, I already told you a lot, but to be honest, what's the point of it? What are the benefits of applications like this? So first of all, they are way more immersive, and this immersiveness can create completely new experiences. Think about training scenarios where you can just rearrange your objects and have a completely different experience. Think about police trainings where you can just rearrange objects on a training site and have a completely different crime scene. That's the first picture from a university in the US where you can simulate different scenes and train students on it. Or think about production lines where you can scan the whole production line and combine physical and virtual production steps and walk through them. Or home staging, where you can literally skip the whole home staging process, just add empty boxes and then offer individualized homes depending on the style of your customers. And all of this offers tremendous differentiation because these applications don't exist yet and you just stand out with these applications. And then since you decrease the triggers of motion sickness, the utilization rate increases. More people can use these applications for a longer time. And maybe the most important part for developers and companies, the payment willingness for these applications increases by up to 20%, and developers are ready to spend more than 40% more time to develop applications like this. And all of this just brings me back to my first question. Is this already synchronization? And the answer is we're on the way to it, but there are a few steps missing to talk about a real synchronization. So let's talk about three different topics. First of all, the automatic object detection. As I mentioned, we do it in a manual way at the moment, as I show you in a few couple of seconds, but the headsets are already capable of scanning the objects around you. We see projects or products like Apple AR Kit that can scan things around you with the LiDAR scanner and even categorizing them. And developers will get access to these informations in the near future, and we can easily implement them and make it even more synchronous to just also include dynamic objects, moving objects, and so on. The second part is, and that plays into this dynamic objects topic, that you have a generation of virtual experiences on the fly. At the moment, you just scan your environment, you render the experiences in a few couple of seconds, and then you're ready to go. But in the future, think about with this automated detection of your environment that you just move around and dynamically see all the objects transforming. And then you can also just go outside, go into a park, and every object around you, wherever you look, is transformed into a virtual world. And the last topic, and it's maybe the biggest vision of the future, is AI-generated content. So we can already see how AI generates 3D objects out of 2D input. And think about this in a VR context. The AI could just take a scene, a setting, recognize it, and automatically build the existing or build 3D objects at the parameters and then automatically generates the virtual world and experience. But to be honest, that's still a topic pie of the future. So let's see what's already possible today. And I want to show you how an application with TwoSync could look like in reality. And now I go just over there and I switch the screen to the headset. Let me put it there. And then we can experience it. Just put this by side. So you see the live stream from this headset, and let me put it on. And maybe put this water bottle around here. And we just start one of our example applications. And I show you what I told you before in reality. So we start a simple game that shows our core functions. And at the moment, it should be capable of see everything I see in the glasses. And now we can start. Let's think about your home environment. That's a game for end customers at home. You scan your surrounding around you. So let's just say here are your walls at home. Of course, this whole booth is a little bit bigger. We could also do this, but I just want to keep it simple. And now we have our walls, everything all around us. And then we have objects, and we could just scan them by using this controller. As I mentioned, that's quite fast. There we have one object. There we have a second object. We can align properties to them. This one is horizontal, and maybe this one isn't horizontal. And to be honest, that's it. We scanned our environment. And now, okay, there are some safety questions, of course. People do things wrong. And now we're at the point to say, that's it. We are in our virtual world now. And I search for the menu. It's on this side. And now the scene generation starts. As I mentioned, a few couple of seconds. And then we are in a virtual world. I hope you can still see everything on the screen. And now we're in the virtual world I mentioned before. Let's just hide the menu. And normally in VR, you either stand and walk in a certain area, or you just sit around. And now you can move around. Of course, that's just a small space, a small demonstration. But think about transforming this whole booth, or think about an environmental company context, and you have all the objects. This was a non-horizontal object, as I mentioned, and that's an horizontal, and it's precisely mapped onto the real world. And as I mentioned, that's a game. I can just play around. That's USK 12, so it should be fine. And we can interact with the objects around you. I can just lay something here in my physical world, a virtual object. And yeah, that's the power of it. I can walk around. We could do this with multiple people. And that's just a simple application. So think about an enterprise context and so on. That's what we wanted to show with these kind of applications. Let me just put this to hold. So thank you very much here at the booth. Thank you everyone who attended online, and have a nice day. And for everybody that's here we can also try it out live. We can go over there and can try it with multiple glasses and yeah, experience it on yourself. That is just a short presentation. Thank you.